Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 6 to 8, which account for 21 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 6a, solve 5x, add 4 equals 2x, add 6. So we know that I like space to do this, so I'm going to carefully write my equation here, just to make sure I don't write anything incorrectly. So we're solving for x, the unknown variable. X appears on both sides of this equation, so the first thing I need to do is eliminate the smallest x term. So we have positive 5x and positive 2x. I know that they're both positive because there's no negative sign in front of them. 2x is smaller than 5x. So that is the smallest x term. That's the term that I'm going to eliminate. So the opposite of having a positive 2x there, the way I'm going to eliminate it is by taking 2x away from both sides. So when I take 2x from the left-hand side, 5x take away 2x is 3x. My plus 4 is still there. I've done nothing with it. It's not an x term, so it's staying where it is. I need to do the same to the right-hand side to balance the equation. 2x take away 2x is 0. We've eliminated that 2x. We're just left with 6 on the right-hand side. Now we've got a two-step equation. To solve for x, I need to isolate the x term. So I'm going to eliminate the add 4 from the left-hand side. The inverse of adding 4 is to subtract 4. So when I subtract 4 from the left-hand side, that cancels out the positive 4 and leaves me with 3x. I have to do the same to the right-hand side to balance the equation. 6 subtract 4 is 2. Now I've got a one-step equation, 3x equals 2. 3x is 3 multiplied by x. The opposite of multiplying by 3 is dividing by 3. 3x divided by 3 gives me x, so that's my x term isolated. I have to do the same to the right-hand side. 2 divided by 3. I'm going to write that as a fraction, guys, 2 divided by 3. If you're not sure what that looks like as a fraction, put 2 divided by 3 in your calculator. Let your calculator show you. I'm going to leave it written as a fraction as my final answer because it doesn't tell me it wants it in any other form. Part B, solve 4x subtract 3 is greater than 17. So 4x subtract 3 is greater than 17. I'm going to solve this exactly as I did here, but instead of an equal sign, I'm going to write my greater than symbol. It's important that I keep the symbol the same. So the first thing I'm going to do here is I'm going to eliminate the subtract 3 on the left-hand side because I'm aiming to isolate the x term. The inverse of subtracting 3 is to add 3. 4x add 3 eliminates the minus 3 is greater than, and then I need to do the same on the right hand side. So 17 add 3 is 20. Again, don't forget, you can do that on your calculator to save your brain power. Now we've got a one-step equation. 4x is greater than 20. 4x is 4 multiplied by x. The inverse of multiplying by 4 is to divide by 4. So when I divide by 4 on the left-hand side, 4x divided by 4 gives me x, which isolates the x. We've still got the greater than symbol, and I need to divide by 4 on the right-hand side as well. 20 divided by 4 is 5. 20 divided by 4. You can do that on your calculator to save your brain power. This whole thing now, guys, is my answer. So if there was an answer line, I'd have to write this whole thing with the correct symbol on there to get the marks. Part C, solve the following simultaneous equations. Use an algebraic, not graphical method. You must show all you're working out. Okay, so when I'm solving simultaneous equations, I'm looking for an x and a y value that works for both equations. The first thing I need to check are the coefficients of the terms. So if I look at the x terms, I've got 5x and 1x. So a coefficient of 5 and a coefficient of 1, they don't match. I'm looking to have terms that have the same coefficient. Let's look at the y terms. Minus 2y, minus 1y. So this is minus 2 coefficient, this is minus 1. They don't match. So now I need to make the coefficients of either the x or the y terms match. I'm going to make the coefficients of the y terms match. I'm going to multiply this equation by 2. When I multiply this equation by 2, everything gets multiplied by 2. So x times 2 is 2x, minus y times 2 is minus 2y, and 5 times 2 is 10. I'm now going to write this equation above it. I'm not going to change this equation in any way, because what you will see here now, guys, is that my y terms both have a coefficient of 2. It doesn't matter what the signs are in front of them, it's the number that's important at this point. They both have a coefficient of 2. So that means I'm now going to eliminate my y term so I can solve for x. So I need to do a sum here. I'm either going to add or subtract. What signs I have here makes me make that decision, okay? So if the signs are the same, we need to subtract. So I've got 2 negatives, we need to subtract. That's why I always change these terms here, because these signs are very helpful. If the signs were different, I'd have to add. So we're going to subtract these equations now. 5x subtract 2x leaves me with 3x. Minus 2y subtract minus 2y eliminates the y variables. 16 subtract 10 equals 6. Now I've got a one-step equation that I can solve for x. I've eliminated that y variable. So 3 times x equals 6. The inverse of multiplying by 3 is to divide by 3. 3x divided by 3 gives me x and isolates x for me. Do the same on the right hand side to balance the equation. 6 divided by 3 is 2. There's no separate answer line here for my x and my y value, so I'm going to highlight that my x value is 2. Okay, final step. We need to find out our y value. So I've got to substitute this x value into one of these two equations. I'm going to use this equation here. So x minus y equals 5. But when x equals 2, that becomes 2 minus y equals 5. I'm aiming to solve this equation for y now, so I need to isolate the y term. So I'm going to eliminate this positive 2. I know it's a positive 2 because there's no negative sign in front of it. So the way I'm going to eliminate a positive 2 is to subtract 2, which leaves me with minus y on the left-hand side. But when I do the same to the right-hand side to balance the equation, 5 subtract 2 is 3. Now the important thing to notice here, guys, is we've got a negative y. That negative sign stays with the y. I don't want a negative y, I want a positive y. This is technically negative 1y. So that's negative 1 multiplied by y. So if I divide by negative 1, negative 1y divided by negative 1 gives me positive y. But I have to divide by negative 1 on the other side. So 3 divided by negative 1 is negative 3. If you're not sure about your negatives, do 3 divided by negative 1 on your calculator just to double check. So that's our y value, y equals negative 3. We can double check this if we want to by substituting both of those values into an equation and checking that we get that correct answer. Question 7. So we have a diagram at the top here, not drawn to scale, so we can't measure anything directly from it. So the question tells us the diagram shows a rhombus ABCD. ABCD. So this is a rhombus. And the first thing I'm going to do is I'm going to mark that all these 4 sides are the same, because that's a property of a rhombus and that might come in handy. All 4 sides are the same. AC and BD intersect at E. So the line from A to C and the line from B to D intersect here at E. The length of AC is 12 centimetres. So this line AC has a length of 12 centimetres. Angle BCE is 35 degrees. So BCE, that angle there is 35 degrees. The question asks us to find the perimeter of ABCD. So we want the perimeter of the rhombus. Now the important thing here is that all 4 sides of that rhombus are the same. And to find the perimeter, we would add all the sides up of the shape to get the total distance around the outside of it. So actually we only need to find one of those sides and then we can multiply it by 4 because they're all the same. So what I'm going to do here, guys, is I'm going to just deal with one side of the rhombus, and you can see that pink triangle that I formed there, because AC and BD intersect at a perpendicular point, and that forms a right angle. So if I look at this triangle here, the pink triangle, I'm working with a right angle triangle, which is going to be handy because there's many things I can do with a right angle triangle. Now I'm just sketching it here just to take it away from the main diagram and make it nice and clear. So that's a right angle. This angle is 35 degrees, and I know this length because EC is half of AC, so half of 12, so that length is 6 centimetres. Now I'm trying to find the side here, guys, of the rhombus. So I'm trying to find that side of the triangle. So we have a right angle triangle. We know another angle. So we're dealing with trigonometry here, guys. So the first thing I'm going to do is I'm going to label my sides. So opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means the remaining side is adjacent to that angle that we know. So we're going to highlight what sides we have information for. So I know that the adjacent is 6 centimetres, and I'm interested in the hypotenuse because that's the length I want to find. I'm not interested in this side at all. So I'm dealing with the adjacent and the hypotenuse. So we're going to use SOHCAHTOA, and I know that the adjacent and the hypotenuse relate to the cosine function. So you might remember this formula triangle if you've used them before. So the cosine function is the adjacent over the hypotenuse. So all I'm going to do with this formula here is substitute in what I know. So the angle that we're given goes with the cosine function. The adjacent is 6, and the h is what we're looking for, which is x. Now if you're comfortable with algebra and rearranging this equation to solve for x, go for it, you can do that. Otherwise you can use this formula triangle to help you. So we're looking for the hypotenuse. So if I cover the hypotenuse, it tells me that to find x, I need to do the adjacent side divided by cosine. So to find x, it's the adjacent side of 6 divided by cosine of the angle 35. And I'm going to pop that into my calculator, guys, and that'll tell me the length of x. I'm going to put it in as a fraction. I'm going to close my bracket that automatically opens with the cosine function. So that tells me x is 7.324647533 centimetres. So remember, that's one side of my rhombus, and I'm interested in finding the perimeter. So I have 4 of the same sides. So the perimeter is equal to 4 times the 7.32, etc. I've kept that in my calculator, so I'm just going to simply multiply that by 4, which is 29.29859013 centimetres. Now the question doesn't ask us to round it in any way, so I'm just going to round it to 1 decimal place. So I'm going to write 29.3 centimetres there for my final answer. Question 8. The table shows some of the values of h equals -3 multiplied by t add 1 in a bracket and t subtract 4 in a bracket for a range of values of t from 0 to 5. So this is our table of t values are from 0 to 5. This is our function, and some of the values have been filled in. Part A, complete the table above. So to complete the table, we're simply going to substitute in the t values to find the appropriate h value. So I'm going to leave it like this. I'm not going to expand it, guys. So when t equals 0, h equals -3, 0 plus 1, I'm replacing that t with a 0, and then 0 subtract 4. I'm going to put it in my calculator just like that, guys. No messing around. So don't forget the minus at the front. 0 plus 1, 0 subtract 4. So that gives us a value of 12. So we're going to put a h value of 12 there. I'm going to do the same when t equals 3. So we have h equals -3. 3 plus 1, because we're replacing the t with 3. 3 subtract 4. And I'm going to do that in my calculator again, but rather than enter it all in, I'm going to go back, and wherever there was a 0, I'm going to enter 3 because my t value is now 3. That also gives me a value of 12. There we go. And then the same for when t equals 5. So h is -3. This time t is 5. I'm going to go back, and the 3's, only the 3's inside the bracket, remember that -3 on the outside isn't a t value, gets changed to 5. So that gives me -18. So that's part A. Part B, on the graph below, draw the graph of h equals -3 multiplied by t add 1 and t subtract 4 for these values. So we're basically plotting these coordinates because that function, that equation, matches exactly. So we're going to plot those values. So these are our coordinates. So we're going along to t and then up or down to the corresponding height. So when t is 0, we're going up to 12. So t is 0, we're going up to 12. Be careful with the scale, guys. So from 10 to 15 is 10 little squares. So 2 squares is equal to 1. So that's 11. That is 12 there. So that's my first point. Then I'm going to go t is 1 and up to 18. So t is 1, 15, 16, 17, 18. T is 2 up to 18. T is 3 up to 12. 11, 12. T is 4. H is 0. And then t is 5, and we're going to -18. So that's -15, 16, 17, -18. So we're going to sketch the curve. Now what you need to do is sketch this in pencil, guys, just in case you make a mistake. It is a curve, so we don't want any straight lines, but it doesn't have to be perfect. It just, snap my pencil, just has to, as best as you can freehand, go through those points accordingly. So that's part B. Part C, Derek throws a ball upwards from a point above horizontal ground. So this is the image that you can see here. The height h meters of the ball above the ground, t seconds after Derek throws it, so h meters, t seconds after he throws it, is modelled by that equation. So the equation that we were working with in part A and B. What is the height of the ball above the ground at the start of Derek's throw? So at the start is important because that's when the time is 0. Okay, so we want to work out h, the height, when t is 0. Okay, so you can substitute it in, or you can go back to your part A. We already worked out what it was when t equals 0. It equals 12. So I'm just going to copy that onto this question again. So h equals -3, 0 plus 1, 0 subtract 4 equals 12. So the height at t equals 0 is 12 meters. Part 2, how many seconds after Derek throws the ball does it first hit the ground? Again, we're going to look back at our table because if it hits the ground, we've got a height of 0, haven't we? So let's have a look. T equals 0 is when Derek's starting. This is 1 second later, 2 seconds later, 3 seconds, 4 seconds, and 5 seconds after throwing it. Okay, so we want to know when the ball first hits the ground. So when it's got a height of 0. So let's have a look. H equals 0. Well, that was t equals 4. So we can say that it was 4 seconds that after he throws the ball that it first hits the ground. Part 3. How many seconds after Derek throws the ball is it at its maximum height? Okay, so this is where we're going to have to go back to our graph because it's a curve and the highest values we can see are at t equals 1 second and t equals 2 seconds, but something will have potentially happened here and we can see it did on our graph there. So what we're going to do is we're going to read down roughly where its highest point would be, and actually it's its line of symmetry, guys, so it's going to be halfway between 1 and 2. All right, so that's when the graph starts, the curve starts to come back on itself. So 12, 18, 18, 12. So this is the line of symmetry. So it's halfway between 1 and 2. So that must be 1.5 seconds. And then part 4, what is the maximum height of the ball above the ground? Okay, so the maximum height of the ball above the ground. So we're going to use our graph to read this off. However, we've roughly drawn the curve. Okay, so this is going to be an estimate, but where we hit our maximum point when t equals 1.5, we're going to read across to that other scale here, and then we're going to read off roughly what we think the maximum height is. So remember, each of the 2 of these squares is 1, so that's 16, 17, 18, 19. So it's roughly 19 meters maximum height. And that one is a range of values that you can have, guys, because everyone might draw this part of their curve slightly different.